charged particles set up an electric field at all points in the surrounding space, even if the space is a vacuum. If we place another charged particle and at any point in that space, it is affected by the electrical field. It means that the second charged particle experiences electric force. Electric field lines extend away from positive charge where they originate and toward negative charge where they terminate. As you see here, positive charge is going away and negative charge, the electric field is going to go toward negative charge. How do we calculate electric field? A point charge is affected by electric field and experiences an electric force. Electric force equals to the charge of the particle times electric field. The electric force is parallel to electric field, and direction of electric field depends on the charge sign. If both of them are positive, they are going in the same direction. If you have positive and negative, you're going to have different direction. So electric field equals to electric force divided by Q1. Electric force, we can derive it like this based on Coulomb's law. K times Q1 Q2 divided by R squared. So these Q1 and Q1 cancel out, and we have K Q2 divided by R squared. And the unit for electric field is Newton per Coulomb.